Hello everyone, good morning. Good morning. First of all, a very happy new year. So I think my voice is audible, right? My voice is audible, right? So we are taking classes after a very long time. Yes, if anyone is watching, if my voice is audible and clear, I think it will be audible. Yes, good morning, good morning. Okay, so we'll start. So we're going to start a new chapter, which is ordinary differential equations, right? So we're going to start a new chapter, ordinary differential equations. So before that, what we'll do is we will just see the syllabus, right? So we'll just see the syllabus of ordinary differential equations, and then we will start the first topic in ordinary differential equations, right? Okay. Good morning. Good morning. Okay. So you can see this is a syllabus, right? So this is a syllabus for ordinary differential equation. So it goes on like formulation of differential equations, equations of first order and first degree, integrating factors, orthogonal trajectory, equations of first order but not of first degree, Clairaut's equation, singular solution, second and higher order linear equation with constant coefficients, complementary functions, particular integral and general solutions, second order linear ODE with variable coefficients, Euler-Cauchy equations, and the method of variation of parameters, right? So this is the syllabus for ODE, and Laplace transforms also comes under the syllabus of comes under the chapter of ODE, right? So first we will finish off ODE and then we'll come back to Laplace and inverse Laplace transforms, right? Okay. So you can see first we are going to start with equations of first order and first degree. Okay. After finishing that, we will come back to formulation of differential equations, right? So equations of first order and first degree. That is, they will give a differential equation of first order and first degree. You need to solve that equation, right? So I'll let you know what is meant by a differential equation of first order and first degree. So uh, the entire classes, right? That is the next upcoming 4 to 5 classes. We are going to find the solution of differential equations of first order and first degree. So there are many methods to solve a differential equation of first order and first degree, right? There are many methods to solve a differential equation of first order and first degree, right? So what I'm going to do is first we will define what is meant by differential equation of first order and first degree. After that, I'll let you know what are the methods that are available to solve a differential equation of first order and first degree. After listing out all the methods, the first method to solve is variable separable method, right? So first what we're going to do, we're going to define what is meant by first order and first degree differential equation. After that, I'm going to list out what are the methods that are available to solve a differential equation of first order and first degree. After listing out all the method, we are going to start solving in the first method, which is called variable separable method, right? So before that, you have to be very, very strong in differentiation and integration formulas, right? So what I'm going to do is, before starting a variable separable method, I'm also going to give you all the basic differential and integral formulas that you come across in 11th and 12th standard, right? I'm going to write down all the formulas. Even though if you are strong in basic differentiation integration, no problem. You just recall all those formulas, right? I'm going to write down all the basic differentiation and integration formulas also, because you need to be very strong in differentiation and integration to find the solutions of differential equations, right? So what we're going to do is first we're going to define what is meant by differential equations of first order and first degree. After defining, I'm going to list out all the methods to solve a differential equations of first order and first degree. After that, I'm going to give you the differentiation and integration formulas. After that, we're going to start solving the first method, which is variable separable method, right? With the syllabus, we're going to start equations of first order and first degree. Is it clear what I'm going to do now? Right? So try to be active so that I will also be active because of you. Right? Okay. So first what we'll do is we will define what is meant by differential equations of first order and first degree. Take a proper notes, take a new note, right? Start new. You just go through my notes, right? You can do any problem in differential equation, right? Just follow my notes. Okay. So first what we'll do is we will define what is meant by a differential equations of first order and first degree, right? Definition. A differential equation of first order and first degree is an equation, right? It is an equation of the form dy by dx equal to function of some x comma y, right? Or it can also be of the form m dx plus n dy is equal to 0, where m is a function of x, where m and n, okay, where m and n are functions of x and y, right? So this is the definition of a differential equations of first order and first degree, right? So what we are meaning by first order is the derivative is first order, right? The derivative is first order. For example, if you have first order means it will be dy by dx, right? Second order means it will be d square y by dx square, right? Third order means it will be d cube y by dx cube. So this is first order, this is second order, this is third order, right? So by the meaning of order means the derivative order, right? So only we are going to focus on first order, right? That is the equation will be of the form dy by dx, and also it is first degree. So degree in the sense that power should be 1, right? For example, if you consider this, right, dy by dx whole power 2, this is a first order, but degree is 2. We are not going to consider this also, right? We are going to only solve a differential equation of first order and first degree, right? So we will only having dy by dx and some function of x comma y, right? And some function of x comma y, right? Okay. For example, if you consider this, right, d cube y by dx cube whole power 4. This is an equation of order 3 and degree 4. We are not going to consider this also, right? Only we are going to find the solutions of first order and first degree differential equation, right? So what we meant by solution is that, right? What we meant by solution is that, I'll give you an example, right? I'll give you an example. What we are trying to do, we are trying to find the solution of differential equations, right? Let us take this equation, right? Let us take this equation. Let us take this equation. X plus 2 is equal to 0, right? I'm taking an algebraic equation. What is the solution for this equation? Minus 2 is the solution for this equation, right? That is, solution means we need to put an x such that this equation satisfies, right? So for this, x is equal to minus 2 is the solution, right? X is equal to minus 2 is the solution. Now similarly, you consider this equation, right? dy by dx minus 1 is equal to 0. So here, what we mean is, we need to find a function y, right? So y is a function of x. If you differentiate that, you need to differentiate that, and then you need to subtract 1, and then you have to get 0 as an answer. What will be the function? Yes, can anyone? You need to find a function y such that you need to differentiate with respect to x, and then you need to subtract 1, and then you need to get 0 as an answer. What will be that function? Yes, I'm looking for comment. Yes, you need to find a function, you need to differentiate that, and then you need to subtract -1 so that you need to get 0 as an answer. What will be the function? Yes. There are many functions, right? There are many functions. Can you tell me one? Yes. Let us take a function y is equal to x. That's it. Right? Yes, Kennedy, good. Y is equal to x. This is one solution, right? That is, if you differentiate x, you will have 1. So 1 minus 1 will be 0. Not only 1, right? Let us take x plus 1, right? You take x plus 1. Again, this will be a solution, right? When you differentiate that, you will have what? 1 again. Again, x plus 2. So in general, x plus c, right? X plus any constant will be a solution for this equation. So in differential equations, we have a family of solutions, right? We have a family of solutions, so that we will be putting an arbitrary constant c, right? It will be a family of solutions. So what we are doing in differential equation is that we are finding a function as a solution such that that function, when you differentiate that and you subtract 1, you have to get 0 as an answer. That's what it means, right? So here in differential equation, the solutions will be a function, right? The solution will be a functions. This is the very important. So here you can see the solution is what? Number. But actually this is we should not say this number, it's a constant function also, no problem. But in differential equations, the solution will be a function. What that function says is, you differentiate that function and whatever question they are giving, that function satisfies the given question, right? Okay. So as of now, what we have seen is what is meant by differential equations of first order and first degree. So the solution in the sense that we have a function, we have a family of function as a solution for differential equations, and you know what is meant by first order and first degree. It will be dy by dx, right? The power should be 1 and it has to be a first order. This is what differential equation of first order and first degree is an equation of the form dy by dx equal to function of x comma y, or m dx plus n dy is equal to 0, where m and n are functions of x and y. Now, there are many methods to solve a differential equation of first order and first degree, right? There are many methods. So, in exam point of view, actually there are 8 methods to solve differential equations of first order and first degree, right? There are 8 methods. I'm just going to list out those 8 methods, right? So, in exam point of view, they will not say solve by this method, solve by this method. You have to find out by looking at the question, which will be the suitable method to solve that equation. That you come to know after doing out all the methods, right? Okay, so solution of, so we can solve by following methods, right? So there are many methods to solve. We can solve by following methods. Is there any doubt up to now? Right, so we can solve by following methods. So there are 8 methods. I'm going to list it out. First method is called variable separable method. Right? Variable separable method. And second one is equations reducible equation reducible to the form in which variables are separated. In which variables are separated, right? So we cannot separate variables by looking at directly, but we can reduce that equation, and then we can use that method 1, right? Equations reducible to the form in which variables are separated. The third one is called homogeneous equations. right? Fourth one is equations reducible to homogeneous. Equations reducible to homogeneous. And fifth one is linear equations. And sixth one is equations reducible to linear equations. Okay, actually 1, 3, 6, 5, right? These are the methods you need to know. Second one is we need to reduce, we can reduce to that variable separable method by substituting some that will come to know, right? That you come to know. Seventh one is exact differential equations. Exact differential equations. Eighth one is integrating factors. Right? So what we're going to do is we're going to solve dy by dx equal to function of x comma y. That is, we're going to solve a differential equation of first order and first degree. We can solve those by 8 methods, right? So in this class, we're going to focus on how to solve by variable separable method, right? So when we can use variable separable method and how to solve a differential equation of first order and first degree by variable separable method. This is what we're going to do. This is what we're going to do in this class, right? Variable separable method. So before starting variable separable method, we will recall all the basic differentiation and integration formulas, right? I'll write it down very fast, right? You know all those formulas. You just have to recall all those, right? Just recall all this so that if when we do problems, it will be easy for you, right? Even if you know no problem, you just try to recall all the formulas, right? Basic differentiation formulas, right? Okay. First is d by dx of x power n, right? So n into x power n minus 1, right? d by dx of f of x whole power n, right? It will be n into f of x whole power n minus 1 into f dash of x, right? I'm using chain rule. D by dx of constant is 0, you know. So d by dx of sin f of x, right? So sin f of x is cos f of x into f dash of x, right? Cos f of x into f dash of x. D by dx of cos f of x is minus sin f of x into f dash of x, right? I'm generalizing this, right? Instead of f of x, if you have x, sin x will be cos x into 1, right? And d by dx of tan f of x. Tan f of x is secant square f of x to f dash of x. So d by dx of cosecant f of x. Cosecant x, right? Minus cosecant f of x cot f of x into f dash of x, right? Seventh, d by dx of secant f of x will be secant f of x tan f of x into f dash of x d by dx of cot f of x minus cosecant square f of x into f dash of x, right? Then d by dx of e power f of x, right? E power f of x. So instead of e power x, I'm writing generalizing to be a function f of x. So e power f of x be e power f of x into f dash of x. Then this d by dx of log f of x. 1 by f of x into f dash of x. So d by dx of root f of x be 1 by 2 root f of x into f dash of x, d by dx of a power x. So it will be a power x log a, d by dx of log ax, right? Log ax. Log f of x means here the base is e. If your base is a, right? Your base is a, it will be 1 by a, 1 by x log a. By x log a, right? 14th, d by dx of sine inverse of x, right? So we list out the formulas for inverse trigonometric function derivatives. It will be 1 divided by root of 1 minus x square, d by dx of cos inverse of x, right? So it will be minus 1 divided by root of 1 minus x square, d by dx of tan inverse of x, right? Will be 1 divided by 1 plus x square, d by dx of cot inverse of x will be minus 1 divided by 1 plus x square, d by dx of secant inverse of x, right? So secant inverse of x will be 1 divided by mod x into root of x square minus 1, and 19th d by dx of secant inverse of x be minus 1 divided by mod x into root of x square minus 1. In both the cases, mod x should be greater than minus 1, right? Sorry, mod x should be greater than 1. And you know product rule and differentiation rule, right? d by dx of f into g be f g dash plus gf dash, d by dx of f by g into f dash minus f into g dash by g square, right? So you just recall all the formulas which will be helpful when we are solving the problem, right? I listed out the basic differentiation formulas. Now we will list out all the basic integration formulas. After that we will solve variable separable method, right? So just take a proper notes and write down all, right? Very, very important all. First is integration of x power n dx will be x power n plus 1 by n plus 1, n not equal to minus 1. Integration of e power f of x dx. So it will be e power f of x divided by f dash of x, right? So in differentiation, we will put multiply. Here we write it as different division. Integration of sine f of x. So integration of f of x will be minus cos f of x divided by f dash of x. Integration of cos f of x dx, right? So if I forgot to write dx, you write dx, right? So it will be sine of x divided by f dash of x. So integration of very, very important formula, right? Integration of f dash of x by f of x dx, right? 50% of the problem in differential equations, we will be using the formula integration of f dash of x by f of x, right? So below we have a function. In the denominator we have f of x. In the numerator we have its derivative, right? This is log f of x. Very important. Log modulus of f of x plus c, right? We just add plus c to all, right? Very, very important, right? Integration of the denominator we have a function, the numerator we have its derivative. In that case, you can write log mod f of x plus c. Sixth, integration of tan x dx, right? Tan x dx. So you can use the above formulas, right? You can use the above formulas. I can write tan x as sin x by cos x. You can see cos x derivative is derivative, right? Minus sin x, but we don't have minus here. So what we'll do is we'll multiply by minus, minus, minus. Now we can see cos x, f of x, f dash of x. This is minus log modulus of cos x, right? Is it clear? You can see I have written tan x as sin x by cos x. So, but derivative of cos, in order to use the fifth formula, cos x derivative is minus sin x, but we don't have minus here, so I'm writing this as minus minus. So let us keep this minus as it is. And I'm going to use the formula integration of f dash of x by f of x is log f mod f of x. So here f of x is cos x, right? Or you can also write this as log. So you can take this minus to the power, and you can write cos power minus 1 as 1 by cos x. 1 by cos x is secant x, right? I can also use this formula secant x plus c, right? Both are, you can use any of the formulas. 7th, integration of cosecant x, integration of cosecant x dx, right? This log modulus of cosecant x minus cot x, cosecant x minus cot x plus c, integration of cot x dx. So be log mod x plus c, integration of secant x dx. So be log mod secant x plus x, right? And then 8th, so integration of secant square x, right? So you know that the integration differentiation are inverse, right? So which function you have to differentiate to get secant square x? Which function you have to differentiate to get secant square x? It is tan x, right? This will be tan x plus. So differentiation of tan x is secant square x, right? You just see this as inverse, right? 9th, integration of secant x tan x. So which function you have to differentiate to get secant x tan x? This secant x, right? Integration of tan square x dx. So which function you have to differentiate to get tan square x? Is tan x minus x plus c, right? And the integration of a power x dx, right? It will be a power x by log a plus c, right? So these are the 11 basic formulas, and then I'm going to list out important integrals. Right? So important integrals. First is integration of 1 divided by, okay, for that formula. All these are very, very important. Save this. Okay. So integration of root of a square minus x square dx. Right. So it will be x by 2 root of a square minus x square. Integration of root of a square minus x square dx, right? So it will be x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c, right? Second is integration of 1 divided by root of a square minus x square. Here we have root of a square minus x square. Here we have 1 divided by root of a square minus x square. This is nothing but sine inverse of x by a plus c. The third is integration of minus 1 divided by root of a square minus x square dx, right? This will be cos inverse of x by a plus c. Integration of 1 divided by a square plus x square, right? So it will be 1 by a tan inverse x by a plus c, right? All these are from inverse differentiation formulas, right? So you can see sin inverse of x is 1 divided by root of 1 minus x square. So what about in general? What about sin inverse of ax? So it will be a square minus x square. When you integrate on both sides, this integration and differentiation will get cancelled. Here you can get the formulas. Okay? That is what these formulas came from. Fifth is integration of minus 1 divided by root of a square plus x square. Be 1 by a cot inverse of x by a plus c. Integration of 1 divided by x into root of x square minus a square dx will be 1 by a secant inverse of x by a plus c. Integration of 1 divided by minus 1 divided by x into root of x square minus a square dx. So this will be 1 by a secant inverse of x by a plus c. Okay. Eighth is integration of root of a square plus x square. So we already seen a square minus x square and 1 divided by root of 1 divided by root of a square minus x square. So here we have a square plus x square dx. Will be x by 2 root of a square plus x square plus log of mod x plus root of a square plus x square. Ninth is integration of 1 divided by root of a square plus x square. Right, so it's reciprocal. So it will be log mod x plus root of square plus a square plus. So 10th is integration of root of x square minus a square, right? So here we have a square minus x square. Here we have a square plus x square and its reciprocals. Just compare and study. Here we have x square minus a square dx, right? So root of x square minus a square dx. So it will be x by 2 root of x square minus a square minus a square by 2 log mod x plus root of x square minus a square plus c. And 11th it's reciprocal. 1 divided by root of mod x square minus a square dx will be log mod x plus root of x square minus a square plus c. 12th is integration of 1 divided by root of x square minus a square. So we know x square plus a square is 1 by a tan inverse x by a plus c. So x square minus a square, right? This will be 1 by 2a log mod x minus a by x plus a plus c. And 13th is the last one. So 1 divided by a square minus x square. This will be 1 by 2a log mod a plus x by a minus x plus c. So that's it, right? So these are the important, these are the major integration and differentiation formulas that we're going to use when we are solving the differential equations, right? All these are very, very important formula. You just have to memorize all those to tackle the problem very easily, right? By looking at itself, you have to make use of the formulas, which one you have to use, right? You have to recall all those. very simple, right? You just compare and study, it will be very easy for. I have written in the order such that it will be easy for you to study, right? So you can see this is root of a square plus x square, and next one will be its reciprocal. Root of x square minus a square, next one will be its reciprocal. And in the format such that it is easy for you to study, right? Okay. So now we will come back to the one that we have started, which is differential equations of first order and first degree, right? So we are going to solve a differential equation of first order and first degree. The solution will be a function, it will be a family of function also, because we are adding an integration constant c. So we can vary c so that we can get an infinitely many solutions, right? Okay. So we can solve by many methods. The first method we are going to solve is how to solve a differential equations of first order and first degree by variable separable method, right? Is there any doubt up to now? Just looking for a comment. If there is no doubt, I'll go. We will start. Um, okay, we'll start variable separable method. So we will do many problems today itself on variable separable method. Okay, so variable separable method, right? So when to use variable separable method, right? So when to use variable separable method. So in an equation, if in an equation, in an equation, if it is possible, right? If it is possible to get all the functions, of x and dx, to one side, and all the functions, of y and dy to other side, right? If in the equation, if it is possible to get all the functions of x and dx to one side, y and dy to other side, then we can use variable separable method, right? If in an equation, if it is possible to get all the functions of x and dx to one side and all the functions of y and dy to other side, the variables are said to be separated. Variables are said to be separated. Variables are said to be separated, right? Then we can use variable separable method. So what is the rule? The rule to solve, in which after separating the variable, how you need to solve. So rule to solve an equation in which variables are separated. Rule to solve an equation in which variables are separated. See, weightage you will get around 40 to 60 marks in ODE, right? I forgot to say 40 to 60 marks only in ODE. Right? For minimum 40 to 60 marks in ODE, right? Okay. Okay, so first is you have to separate x and dx to one side and y and dy to other side, right? So given the differential equation, dy by dx is equal to xy, right? Here x is a function of x and y is a function of y, right? So x is a function of x, y is a function of y. Now what you do is you bring all the x and dx to one side and y and dy to other side, right? This you bring like this, right? So that is you bring all the y and dy to one side, x and dy to other side. Here x and y are functions of x and y, right? Okay. Integrate on both sides, you will get the solution. Very, very easy, right? Integrate on both sides. So it will be integration of dy by y, integration of x into dx plus c is the required solution. That c is the arbitrary constant. That's it, right? We're going to solve problems based on variable separable method. So if in an equation, if it is possible for you to separate x and dx to one side, y and dy to other side, so that means you will have functions of x dx, functions of y dy. So integrate on both sides, you will get y. Y is the solution, right? Y is the solution we need to find, right? So it is not always possible to separate the variables easily. It is possible to separate means you can use variable separable method, right? For example, okay, first we will do many problems so that you will come to know more about this, right? Okay, so we'll start solving problems, right? That's it. So problems. We're going to do many problems. Right? First, solve dy by dx is equal to e power x plus y plus x square e power y, right? So what we're going to do is we're going to solve all these problems by variable separable method only. We will solve this, right? So how to do? So we need to separate x and dx to one side, functions of y and dy to other side. So we will be having dy by dx is equal to, so e power x into e power x into e power y plus x square e power y, right? First, you have to separate the variables. So you can, if you take e power y outside, we will have e power x plus x square. So here we have dy by dx. So what I'm going to do is I'm going to bring all the y's and the dy's to other side, x and dx to other side. So we will have dy by e power y is equal to e power x plus x square dx. Now you can see the variables are separated, right? Variables are separated. Why? Because you can see if it is possible to get all the functions of x and dx to one side, y and dy to other side. So you can see functions of x dx, functions of y dy. Now what you have to do? Integrate on both sides. That's it, right? So we integrate. So what we mean is we need to find a function y as that if you differentiate with respect to x, you have to get e power x plus y plus x square e power y as an answer. What is the function that is the one we are finding now, right? So integrate, so it will be integration of e power minus y dy is equal to integration of e power x square dx. So integration of e power minus y is e power minus 1, e power minus 1 by minus 1, right? E power integration of e power f of x. So integration of e power f of x is e power f of x by f dash of x. So e power f of x into f dash of x, derivative of minus y is 1. E power derivative of integration of e power x is e power x. Integration of x square is x cube by 3 plus constant c, right? This is the required solution. See, if you want to find y means you can take log on both sides, right? So e power minus y is equal to e power x. You can stop at this stage, but if you want to find y means you can take log on both sides, to get a function y, right? That you don't need to do. You can stop at this stage itself, right? So you can see after separating the variables, you have to integrate to get the answer. Second problem is dy by dx by dx equal to e power x minus y plus e power 2 log x minus y. Right? So solution. So we have dy by dx is equal to e power x into e power minus y. So this I can write this as e power log x square minus y, right? So e power log x square minus y. So e power x into e power minus y plus this I can write this as e power log x square into e power minus y, right? E power a plus b is e power a into e power b. And e power log x square is only x square. So we will, if I take this e power minus by outside, so we will have e power x plus x square, right? E power log x is x. So again, we have dy by dx. So we have dy by e power minus y is equal to dy by e power minus y is equal to e power x plus x square dx. Again, you can see the variables are separated, right? Variables are separated. So integrate this. So integration of, so if I bring this to above, we have e power y dy. So integration of e power x plus x square dx will be e power y. This will be e power x plus x cube by 3 plus c is the required solution. Right? On to third problem. So integration of solve y minus x into dy by dx is equal to a into y square plus dy by dx, right? So all the problem we are going to only solve by variable separable. So that means we can separate x and dx to one side and y and dy to other side. So we have y minus x into dy by dx, a into y square, a into dy by dx. So take this term that side, bring this term that side. So you will have y minus ay square is equal to a into dy by dx plus x into dy by dx. So 1 y minus ay. So if I take this dy by dx, we have a plus x, right? So we need to separate dy's and dx, right? Okay. So you bring this you bring this dy. Here we have y into 1 minus ay, right? Here we have dx by a plus x. Now you can see we have separated y's and dy's. We need to integrate, right? So integrate. So integration of 1 divided by y into 1 minus ay dy, integration of 1 divided by a plus x dx, right? As I said earlier, this formula plays a very important role. Integration of f dash of x by f of x dx is log f of x. So you can see derivative of a power x is what? 1. A is constant here. So derivative of a power x is a plus x is 1, which is in the numerator. So I can write this as log a plus x, right? Now we need to find its integral, right? Because this is log a plus x or mod a plus x, right? Or mod f of x. Mod a plus x plus c. Now we need to integrate this, right? Now remember, whenever you have some functions like this, right? Now what is the degree of numerator? What is the degree of numerator? It is 0, right? Because constant is 0 degree. And what is the degree of denominator? It is 2, right? We have y square term. So that means whenever if you have something like this, right? Numerator by denominator, and if degree of numerator is strictly less than degree of denominator, use um, use partial fraction. Use partial fraction, right? If degree of numerator is strictly less than degree of denominator, use partial fraction. If degree of numerator is greater than or equal to degree of denominator. Very, very important note, right? This you can learn only from practice, but I'm giving you straight away. If degree of numerator is greater than or equal to degree of denominator, use division algorithm. Actually, if degree of numerator is less than degree of denominator, it is called proper rational function. Is called proper rational function, right? If the degree of numerator is strictly less than degree of denominator, you will call that as proper rational function. If degree of numerator is greater than or equal to degree of denominator, it is not proper rational function. Use division algorithm to reduce to proper rational function and to partial fraction, right? I'll explain you very clearly, right? So whenever you have numerator by degree of, whenever you have a rational function, right? So whenever you have a rational function, what is meant by rational function? F of x by g of x. Integration of f of x by g of x. And if degree of numerator is strictly less than degree of denominator, means it is called proper rational function. You can do partial fraction directly. If not, you have to use division algorithm to reduce to proper rational function and then do partial fraction, right? I'll explain you the help of the problem, right? Next 2 or 3 problem, we are only going to make use of this method, right? Okay. Now here you can see this is a proper rational function, right? Degree of numerator is 0, degree of denominator is 2. So 0 is strictly less than 2. That means you can directly make use of partial fraction to integrate this, right? Okay, now you will integrate this, right? Now to integrate 1 divided by y into 1 minus ay dy. Now to find this, you have to make use of partial fraction, right? So how you write 1 by y into 1 minus ay? This is a by y plus b divided by 1 minus ay. Right? This is how you write partial fractions, right? 1 by y, 1 by a. That is, here you can see both are non-repeated roots, right? So that means a by y plus b into 1 minus ay. Partial fraction is very simple. Suppose if you have squared means it will be type 2 partial fraction. You come across in 11th standard itself, right? Now to find a and b, so multiply by whatever you have in the denominator, you multiply throughout, right? Multiply by this. That means when you multiply throughout by y into 1 minus ay, this y into 1 minus ay and this y into 1 minus ay will get cancelled, right? Let us write it. I'm going to multiply throughout by y into 1 minus ay. This term will get cancelled, y by will get cancelled, this term will get cancelled. So we will left with 1 a into 1 minus a. Now we need to find a and b, right? Now we need to find a and b. So put y is equal to 0. This term will be 0 when y is 0. And this term will be 0 when y is 1 by a, right? That is how you find the constants a and b. So when you put y is equal to 0, we have a into minus 0 plus b into 0 implies the value of a is 1. And you put y is equal to 1 by a, right? So that this will be 0, right? This term will be 0 when y is 0. This term will be 0 when 1 is equal to ay, y is 1 by a. Term will be 0. So we will be left with b is equal to a. So therefore, I can write 1 by y into 1 minus ay as a by y plus b divided by 1 minus ay. So a is 1, so 1 by y, b is a, so a divided by 1 minus ay, right? So therefore, what about the integration? Now integrate on both sides, right? Now you can see it's reduced to proper rational function, right? Okay, write it down. Integration of y into 1 minus ay dy So integration of, so I can write 1 by y into 1 minus ay as 1 by y plus a divided by 1 minus ay dy, right? Now it is easy to integrate, right? So integration of 1 by y dy, integration of a divided by 1 minus ay dy. So what about integration of 1 by y? It is log y, right? And what about this? Now you can see f of what its derivative? It is minus a, but you have plus a here, right? So you can see integration of f dash of x by f of x is log f of x, but here you should have minus in the numerator. So what I'm going to do is I'm going to write this as like this, right? So this will be log y minus log mod 1 minus ay plus some constant c. This is the integral value. This is the required solution, right? Substitute in 1. Substitute in 1. You can also put log mod y also, right? Log mod 1 y is equal to log mod a plus x plus b. Is the required solution. If you want, you can also make use of log a minus log b formula, right? Log a by b. Right? You can also make use of that to simplify more, right? It's a required solution. Or log modulus of 1 minus ay equal to log modulus of a plus x. Instead of c1, let us put some log c1, and then you can also bring this down to this side. You can do anything, right? Or you can also write this as c1 into mod a plus x. Log a plus log b is log ab, right? Log a plus log b is log ab. So log c1 into mod a plus x. This log will get cancelled. You will have y by 1 minus ay is equal to c1 into mod a plus x, right? You can reduce more also. That's it, right? So whenever if you have a rational function, right, that is f of x, g of x, and if degree of numerator is strictly less than degree of denominator, use partial fraction. If not, use division algorithm to reduce to proper rational function and then do partial fraction. What is proper rational function? Degree of numerator should be strictly less than degree of denominator, right? Okay, so we will do one next problem. Okay, so 1 minus x square, fourth problem. 1 minus x square into 1 minus y dx equal to xy into 1 plus y dy. So we need to solve this, right? So we need to solve 1 minus x square into 1 minus y dx equal to xy into 1 plus y dy. Okay, so we'll do this. So we need to separate x and dx to one side, y and dy to other side. So you can see, let's keep this 1 minus x square by x dx. Here we will have y into 1 plus y by 1 minus y dy, right? So we have separated functions of x and dx to one side and functions of y and dy to other side, right? Minus x square dx by x, 1 plus y dy to 1 minus y dy. Now we need to integrate this. So integration of 1 minus x square by x dx, integration of y into 1 plus y by minus y dy, right? This is very easy to integrate, right? And separate this 1 by x square minus 1 x will get cancelled. So 1 by x square, 1 by x minus x dx. And what is audible, right? Hello, hello, hello. And what is audible, right? So 1 minus x minus x dx is equal to integration of y square plus y divided by minus y plus 1 dy. This is log x minus x square by 2. Let us add some constant c. integration of y square plus y divided by minus y plus 1 dy. Now remember, this is a rational function. We have f of x by g of x, but it is not proper rational function. Right? Degree of numerator is 2, degree of denominator is 1. So in that case, we will fall here, right? If degree of numerator is greater than or equal to degree of denominator, use division algorithm to reduce to proper rational function and then do partial fraction, right? So you have to use division algorithm to reduce this to, this is not a proper rational function, right? Not a proper rational function. Why? Because degree of numerator is strictly greater than degree of denominator, right? My voice is audible or not clear, right? Can anyone tell? One is saying that proper volume. Okay, so we need to reduce this to, we have to do division algorithm here, right? So how to do is you have to divide this. You have to divide y square plus y divided by minus y plus 1, right? Okay, thank you. So you have to use proper rational function. It is not a proper rational function, so you have to use, thank you, thank you. What you have to do is, to integrate this, right? We have to integrate this, right? We have to integrate this. So let us call this as I, right? Let's call this integral as I. So we need to find the integral values of I, and we need to substitute back here. Now, it is not a proper rational function because degree of numerator is greater than degree of denominator. We divide, right, minus y plus 1, y square plus y, right? I'm going to make use of division algorithm. So minus y into what is y square is minus y, right? Minus y into what is y square is minus y. So it will be y square minus y. Subtract this will get cancelled. This will be 2y. So minus y into what is 2y? It is minus y into 2, right? Minus y into 2y, 2 is 2y. This will be minus 2. So you have to use division algorithm. If this degree is 1, right? Okay. Subtract this. It will be 2. So this degree is 0. This degree is 1. So you can stop at this stage, right? So whenever this degree is less than this degree, that is remainder degree, you can stop dividing, right? But here you can see this degree is 1. This degree is also 1. So you have to perform once again, right? Okay, that means what division algorithm says? What division algorithm says? That is, when you are dividing, let's take two numbers, right? 10, 4. 4 2s are 8. Remainder is 2. That means 10 can be written as 4 into 2 plus remainder. Is 4q plus remainder. 4 into quotient plus remainder, which is 4 into 2 plus 2. This is what division algorithm says, right? Is b is equal to aq plus r. What is a? This b, this a, right? So similarly, y square plus y can be written as minus y plus 1 into quotient plus remainder, right? So you just see which number is inside, that is equal to this into quotient plus remainder. So what is quotient here? Quotient is minus y minus 2, remainder is 2, right? Remainder is 2. That means I can write y square plus y as like this, right? Let us replace that again. Let us replace there. What is I? I is integration of y square plus y divided by minus y plus 1 dy. So integration of, I can write y square plus y as minus y plus 1 minus y plus 2 plus 2, right? So with the help of division algorithm, I have written y square plus y as minus y plus 1 minus y minus 2 plus 2 divided by minus y plus 1 dy. Now divide separately, these two will get cancelled. We will have what? Minus y plus 1 y minus 2 divided by minus y plus 1 dy, integration of 2 divided by y plus 1 dy. These two will get cancelled. So integration of minus y will be minus y square by 2. So integration of minus 2 dy is minus 2y. And here you can see f of x, f dash of x, f of y, f dash of y. Derivative is minus 1, but we don't have minus here. So let us take this 2 outside. Let us write this as minus 1 divided by minus 1. Call this as minus 2. So minus minus. So now we can see f of y, f dash of y. So this will be minus y square by 2 minus 2y. You can see after dividing division algorithm, this is converted to proper rational function. That is the beauty of division algorithm, right? So originally it is not a proper rational function, as your degree of numerator is greater than degree of denominator. But after doing division algorithm, it is converted to proper rational function, right? So minus 2y minus 2 times log of odd y plus 1 plus c. This is the integration value for I. So this is the required solution, right? Substitute in 1. So log x minus x squared by 2 plus c is equal to I minus square by 2 minus y minus 2 times log odd y plus 1, the required. Is it clear? Let's check the solution. Minus y squared by 2 minus 2y minus 2 log odd y plus 1 is equal to log x minus s. This is the required solution, right? Is it clear? Very simple, right? Whenever you have a rational function, you have to do partial fraction. If it is simple, proper rational function, if not, make use of division algorithm to reduce to proper rational function and then integrate. Fifth problem. X square into y plus 1 dx plus y square into x minus 1 dx is equal to 0, right? So let us try to bring x dx square into y plus 1 dx is equal to minus y square into x minus 1 dy. So x square dx divided by x minus 1 is equal to y square by y plus 1 dy, right? Y square by y plus 1 dy. Let's keep minus here, right? Now integrate this. So integration of, let us get minus outside, x square divided by, okay, let us try to do like, okay, let us keep this x minus 1 dx is equal to integration of y square by y plus 1 dy, right? So again, you can see both integral is not, both are rational functions, right? Because numerator is also a function of x, denominator is also a function of x. And in the second case, both numerator and denominator are functions of y. Both are both are rational function, but both are not proper rational function. As you can see, degree of numerator is strictly greater than, it can also be equal also, but here it is strictly greater than degree of denominator, right? Okay. So what we will do is, okay, let us call this as minus I1 is equal to I2. So we will find I1 and I2, right? So what is I1? I1 is integration of x square divided by x minus 1 dx, not a proper rational function. because since degree of numerator is strictly greater than degree of denominator. So we will use division algorithm. So you have to divide x square by x minus 1. So it will be x into x is x square minus x multiply by minus, it will be plus. Now this degree is 1, this degree is 1. So you have to perform once again. X into 1 is x, right? So it will be x minus 1 minus 3 plus 1. This degree is 0, this degree is 1. We can stop at this stage. That means x square can be written as x minus 1 into quotient plus remainder. So x minus 1 into quotient is x plus 1, remainder is 1. So instead of this x square, you have to replace here, right? So I1 will be integration of, instead of x square, you have to replace x minus 1, x plus 1 plus 1 divided by x minus 1. Now divide separately. This x minus 1 will get cancelled. So we have x plus 1 dx. Now if we divide this separately, we have 1 by x minus 1 dx. This will be x square by 2. This will be x, will be log x minus 1. Okay? This is the I1 value. Now similarly, you find I2. Now what is I2? I2 is integration of y square divided by y plus 1. Again, it is not a proper rational function. It is a rational function, but not a proper rational function. Whenever you have function by function, it is proper rational function. It is a rational function. Proper means degree of numerator should be less than degree of denominator. Okay, so divide y square by y plus 1. Y square plus y. That this one will have minus y, have minus y minus 1. This will be plus 1, right? Y plus 1 by y square. So y into minus y. So that means this y square can be written as y plus 1 into quotient plus remainder. So y plus 1 into quotient is y minus 1. Remainder is 1, right? So similarly, you just replace this y square to be this term. So your I2 will be okay. So you replace this y square to be this term. So your I2 will be integration of y square by y plus 1 by integration of y square is y plus 1 into y minus 1 divided by y plus 1 dy. Now when you divide separately, this y plus 1 will get cancelled. We will have integration of y minus 1 dy, integration of 1 by y plus 1 dy will be y square by 2 minus y plus log y plus 1. So separate, substitute in this one, substitute in 1 the required solution. I just substitute this I1 and I2 value, that will be the required solution. Is it clear up to now? So whenever you have a rational function, you go for partial fraction, right? If not what? Convert to proper rational function and do whatever you want to. Sixth problem. Secant square x tan y dx plus secant square y tan x dy is equal to 0. So you bring x and dx to one side, y and dy to other side. Let's give the secant square dx. Secant square x tan y dx is equal to minus secant square y tan x dy. Let us give this secant square x dx divided by tan x. You always keep this minus in the dx term, right? Here we have secant square y divided by tan y dy, right? So integrate this. So integration of secant square x by tan x dx, integration of secant square y by tan y dy. Again, you can see f of x, f dash of x, right? Tan x secant square. We log mod log tan x, right? Will be log tan y plus we will add some constant c. Whenever you are adding a log, whenever you are having log, you just put constant to be log c. So if you bring this to this side, you can also perform log a minus log b, right? So that means log c is equal to log tan y plus log tan x. There's no problem, right? Even if you bring this side, you'll have minus log c. These are constants. So log a by b is equal to log a plus log b is log ab, which is log of tan x tan y. Therefore, c is equal to tan x tan y. It's the required solution. Just don't forget the formula. Integration of dash of x by f of x dx is log f of x. Mod f of x or f of x, right? No problem. We move on to seventh problem. dy by dx equal to x into 2 log x into 2 log x plus 1 divided by sin y plus y into cos y. Right? Now you will just separate x and dx to one side, y and dy to other side, and then integrate on both sides to get the solution. So we have sin y plus y cos y dy is equal to 2 into x log x plus x dx, right? Now integrate this. You can see this we have reduced, right? We have reduced variables are separated here, x and dx, y and dy. Integrate this. Integration of sin y dy, integration of y into cos y dy. So 2 is constant here. Integration of x into log x, integration of x dx. So you know integration by parts, right? So integration of u dv is equal to uv minus integration of v du. You have to choose u in the order I late, right? That is I stands for inverse function. Whenever you have inverse function, you have to take that as u. If not, search for logarithmic. If not, search for algebraic. T stands for trigonometric. E stands for exponential, right? Here you have to use integration by parts. Here also you have to use integration by parts. So integration of sin y is minus cos y. Let us call this as I1. Let's call this as I1. Call this as I2. And integration of x dx is x squared by 2 plus some constant. Now you will find I1 and I2. So I1 is integration of y into cos y dy. So here we have algebraic function, trigonometric function. Which comes first? Algebraic first comes first. That means you need to choose u as y and dv as cos y dy. right? Integration of u dv. So you choose u in this order. So what about du? That is, you differentiate with respect to y. So du by dy is 1. That means du is equal to dy. Here you have to integrate, right? Because you need to find the value of v. So integrate this. You have to differentiate here. You have to integrate here. It's very simple, right? Integration of cos y dy will be v is equal to sin y, right? V is sin y. So this formula will be uv minus integration of v du. What is u? U is y. What is v? V is sin y minus integration of what is v? Sin y. What is du? Du is dy. Means y into sin y. What is integral of sin y? This minus cos y, right? That means this will be plus cos y. This is the integral value of y, integration of y cos y dy. Now similarly you find I2. So I2 is integration of x into log x dx. Now we have algebraic function and we have logarithmic function, but logarithmic comes first. That means you have to choose u to be log x and dv to be remaining, which is x dx. Right? Clear? U dv, choose u in this order and you take remaining to be dv. Right? You take remaining to be dv. So what about du by dx? Differentiate with respect to x. This will be 1 by x. That means du will be dx. Du will be dx by x. Right? What about integration of dv is integration of x dx. So v is x square by 2 will be uv minus integral v du. So u is log x, v is x square by 2, integration of v is x square by 2, du is dx by x, 1x will get cancelled, x square by 2 log x minus 1 by 2 integration of x dx is x square by 2, right? This is the integral value for this. So this will be x square by 4. Substitute I1 and I2 in 1. Right? So substitute I1, I2 in 1. 1 is the required solution. Right? So substitute this I1 and I2 value. That will be the required solution. Right? Take the solution. Is there any doubt up to now? Okay. We move on to next problem. Y minus x y minus x into dy by dx into x is equal to y. Right? Into x is equal to y. Yes, I'll upload the PDF in Telegram group after the completion of this class, right? You can download in PDF, the PDF of this Telegram group. Okay, so we will solve this. Again, we are going to solve everything by variable separable method. That is what I am saying. If you are strong in integration, basic integration means these problems are very easy, and understand the concept of proper rational function, right? If it is not a proper rational function, use division algorithm to convert to proper rational function and then integrate. So here we have xy minus x square dy by dx is equal to y. minus y. Yes. So we have xy minus y is equal to x square dy by dx. So if I take this y outside, we have x square dy by dx. So bring this y to that side. So dy by y equal to, bring this dx to that side. We have x minus 1 by square dx, right? What about the 10 question? Still Ragman, what are you asking? I'm not getting your. Integrate this. See, even though it is not a proper rational, this is a proper rational function, right? Degree of numerator is strictly less than degree of denominator. So you can do this, divide x square separately. That's it. So if you divide x square, this will be x by x minus x power minus 2 dx. Again, everything is very easy problem. On ninth problem. Solve 3 e power x tan y x equal to plus minus e power x secant square y dy equal to 0. Let us take x dx to one side. So 3 e power x and y dx equal to 1 minus e power x divided by secant square y dy, right? Secant square y dy. So you just write this as e power x minus 1 and then you cancel this minus. Let's keep this e power x dx. Bring this e power x here. Let's keep this secant square y dy and bring this tan y here. Right? So integrate, you'll get the answer. So integration of e power x by e power minus x, e power x minus x, integration of secant square y by tan y dy. So this is log e power x minus 1, right? Log e power x minus. You can see f of x, f dash of x. Again, this is log tan y. I think I forgot it. Right? This will be log tan y. Let us add some constant log c. This is log e power x minus 1 whole cube. This log a plus log b is log ab, c into tan y. Log will get cancelled. So tan y is equal to some c into e power x minus whole cube is the required. On to 10th problem. X square minus yx square dy. See, in all these problems, it is possible for us to separate x and dx, y and dy to other side. But it is not always easy to separate those variables, right? I give you an example. Let us take this problem, right? Dy by dx is equal to xy plus y plus xy square. Now you can see it is not possible to separate. Is it possible to separate? Take xy outside. Here it is possible. Okay. Let's take x cube y, right? Now you can see it is not possible to separate x and dx, y and dy to the other side, right? So you can take x y common. So we will be left with x square y plus y. Now it is not here. It is not take xy outside. Now square x square plus y, right? Now you can see it is not possible for you to separate x and dx to one side, y and dy to other side. If you bring this x square plus y to the new denominator, you will have x and y term, both the terms. So for this problem, it is not possible to separate the variables, right? It is not always easy to separate the variables. It is easy means you can do integration on both sides, right? If you take this problem, it's not possible to what? Separate the variable. Separate the variable in the sense that bringing x dx to one, that is functions of x and dx to one side, functions of y and dy to the other side. This is a function of both x and y. Right? This is a function of both x and y. Let us try to do this problem, right? So we'll come back to this. So x square minus y x square dy is equal to minus of y square plus x square dx. To take this x square outside, we have 1 minus y dy. To take this y square outside, we have 1 plus x dx. So let us bring this x square by 1 plus x, right? X square by 1 plus x plus, okay, plus x dx. Plus x by dx should always be the numerator. 1 plus x dx by x square is equal to, let's keep this minus of 1 plus x dx by x square, 1 minus y by y square dy. Now integrate this. The integration of 1 by x square, x, 1x will get cancelled. Will be integration of 1 by y square minus integration of by y dy. This will be integration of x power minus 2 dx, be log x, the integration of y power minus 2 dy will be log y. So this will be x power minus 2 plus 1 by minus 2 plus 1. Actually, minus is common here. It minus. Again, this is y power minus 2 plus 1 minus log y. So this will be minus will get cancelled. So we have 1 by x minus log x. Here we have minus 1 by y minus log y. So if you take it to that side, you take it to this side. So we have 1 by x minus x plus 1 by y. And if you bring this to that side, it log y minus log x equal to some constants. The required solution. Is it clear? Can you stop or continue? We have solved 10 problems on variable separable method. Again, we are going to solve more problems on variable separable method. Can you stop here or continue? Yes, you just recall what we did so far. So we have introduced the syllabus of ODE, and then we have introduced what is meant by a differential equation of first order and first degree. After that, we have said there are many methods to solve. The first one is variable separable method, and the equation reducible to the form in which variables are separated, and homogeneous equations, equation reducible to homogeneous equations, linear equations, equations reducible to linear, and then the exact differential equation and integrating factor. So we are solving variable separable method in this class. Before that, I have introduced the basic differentiation and integration formulas, and then I have given you when the variables are separated, right? So if you can bring x and dx to one side, y and dy to other side, then we say the variables are said to be separated. After separating the variable, you have to integrate on both sides, right? So we have solved almost 10 problem. So you just remember what is meant by a rational function, right? Whenever you have f of x by g of x, that is rational function. Proper rational function means degree of numerator should be strictly less than degree of denominator. In that case, you can directly integrate by partial fraction, or by using the formula integration of f dash of x by f of x is log mod f of x plus. If not a proper rational fraction, you can go for division algorithm. After performing division algorithm, it will be converted to a proper rational function, and then you can integrate, right? That is what the third, fourth, and fifth problem is about. And the sixth, seventh, eighth are very easy, right? Integration by parts. Then okay, we'll stop here, right? In the next class, we'll continue from 11th problem, right? 11th problem. We'll continue 11th problem in the next class. I thought of taking 2 hours. One of them is active, right? So you are active, I can continue. One is responding, no problem. We will stop here. Next class, we will start with 11th problem. From 11th problem, we'll continue in the next class. Okay, so thank you. Thank you. Next class, we'll see next. Okay, thank you. All the best. Thank you. If you haven't joined Telegram group, you can join Telegram group. Description I given in the description. I have given you the link for Telegram group, right? You can join Telegram group. And I also given you the question bank for linear algebra, and I asked you to practice 10 questions a day. If you are ready, you can practice 10 questions from Monday, and you can send those solutions, right? Okay. So next class solution, I will update in the group, right? Next class timing. Next class timing, and update in Telegram group, right? Because tomorrow morning 8 o'clock, have one need to go for one checkup, normal checkup. I don't know whether I can take class tomorrow morning. If not tomorrow alone, I'll take evening class, right? Tomorrow alone, I take evening. From Tuesday onwards, we will start our regular timing, morning 8 to 10, right? From Tuesday onwards, we will start with the regular timing. So tomorrow alone, I can't take morning, right? I need to go for an hospital for checkup, normal checkup. Okay, thank you. Right. So in the Telegram group, I'll update. I'll give this PDF in Telegram group, and then I'll uh, update about tomorrow class timing. Right. Okay. Thank you. Bye.